Hi, everyone. My name's Ross Walton, and I am a senior application scientist at Unchained Labs. It's my pleasure to be your moderator for today's seminar, and I want to thank all of you for joining us. Just to let you know, we will be having a Q&A session at the end of the presentation. To ask questions, all you have to do is click on the Q&A button in the Zoom navigation bar. That'll either be at the top or at the bottom of your screen, and then just type in your question. When you submit your question, please avoid clicking the anonymous button, which would, of course, submit your question anonymously. That way, in case we aren't able to get to your question, we'll be able to reach out to you via email and answer it that way. Of course, we'll get to as many of your questions as we possibly can. Now, I'd like to introduce my colleague Brian, who is the product manager for Unagi and Big Tuna at Unchained Labs. Today, Brian will be talking to us about hands-free buffer exchange and concentration of proteins on Unagi and Big Tuna. He'll show us how Unagi's software gives you precise process control and makes sure that you have consistent exchange and concentration targets, even when you're running a bunch of samples at a time. He'll also be showing us examples of runs from both the instruments where the proteins are then taken for further downstream testing. All right, with all of that, let me hand things over to Brian. Hi, Brian. How's it going?
Hey Ross, how you doing today?
I am doing well. I'm excited to hear you talk about buffer exchange.
Absolutely. Thank you for the introduction. Yeah, let's go ahead and kick it off. I am going to be talking today about how you can burn through buffer exchange with both Unagi and Big Tuna. So I think we've all been in a similar situation to this, right? You have a group of friends, you want to get together, make some dinner plans, and you set up a group chat in order to do so. You propose, that we should go out to dinner, and then you get this rush of text messages where everybody has a different idea of what they want to do, right? Different places they want to go, different kind of food they want to eat, different time they want to go. And this quickly turns into, trying to herd cats, getting everybody together into one consensus. This is very similar to the process, and it reminds me of doing buffer exchange using traditional methods in the lab, right? Each one of your samples is unique, they have different preferences, and getting them all exchanged at the same time using traditional methods really requires a lot of control and babysitting of those samples, and really takes up a lot of your time. So we know that buffer exchange is an essential process, right? So it's one of these processes that in the labs that we talk to, there are a lot of people that feel that this is really the biggest bottleneck that they have in their lab, right? Being able to do manual buffer exchange takes up a ton of the time in their labs. And, Unchained Labs really, took this and, heard this pain from a lot of labs and developed an automated buffer exchange platform in order to be able to buffer exchange these systems in a more consistent fashion, in a hands-free fashion, so that you can buffer exchange these while also doing other tasks in the lab at the same time. So when we talk about buffer exchange, what it really comes down to is, taking whatever buffer that your sample is in, removing that, and replacing it with a buffer that you want to. All at the same time, making sure that the sample quality is remaining high, and also we are achieving the highest yield that we can from those samples as well. So whether we are working with proteins and antibodies, whether you're working with nucleic acids, viral vectors in a gene therapy lab, or with lipid nanoparticles, all of these require that same basically core buffer exchange of removing the sample and or removing the buffer and replacing that while keeping the sample quality high. So manual methods are what we commonly see in the lab that people are still doing these days. And, to be honest, there are some benefits to it, right? So if you look at either dialysis or centrifugation, this is equipment that a lot of people already have in their labs, right? Whether it is these dialysis cassettes, a tabletop centrifuge, but at the same time, these also come with limitations as well, right? So when it comes to dialysis, if you are doing buffer exchange with dialysis, that can typically take 1 to 2 days to get your sample fully exchanged. You have to replace that dialysate every now and then, and it's just a longer process. Also, another issue that we have with dialysis is, a lot of times when you're pulling out your sample, you're going to get more volume than what you initially put in, right? So what that means is your sample is essentially getting diluted during that dialysis process. So that's going to require a concentration step afterwards. When it comes to centrifugation, also, it's a benefit of this is it's a much faster process. We do have those centrifuges in the lab. Everybody has they're readily available. But, there are some issues with centrifugation as well. So, for example, samples tend to clog up against that membrane, so that requires a lot of babysitting to be able to make sure that sample is homogeneous. So that takes up more of your time in the lab too to make sure that your samples are homogeneous, make sure that those are not running dry, especially when you have samples that are flowing at different flow rates. You really have to optimize it depending on, the samples that you're currently running at that time. And then TFF is another option. So traditional TFF is typically done in larger formats, so you need a lot more sample, and this can be a lot more complicated to set up as well. So it needs, some basal level of training in order to be able to, effectively use a TFF system. So that's where Unchained Labs comes in with the platforms for buffer exchange that we have, both Unagi and Big Tuna. I'm going to talk about both of these today individually and talk about, how they differ from each other and, which type of lab they're really intended for. But at the end of the day, one of the key takeaways I want to, get across is the fact that these are using the same core buffer exchange technology within both of them. So let's first talk about Unagi, right? So Unagi is our benchtop buffer exchange system that basically takes that buffer exchange process and automates the whole thing, right? So this is going to keep it hands-free, consistent, and easy for your buffer exchanges. So everything from adding buffer, concentrating your samples down, all of this is done automatically in Unagi on up to 8 samples at the same time. So, really what you can work with here is anywhere from half a mil up to 48 mils of sample, depending on the experiment that you're doing. And all of this really only requires less than 15 minutes of hands-on time to be able to load your samples and put them in the instrument, hit start, and let Unagi take the helm. So Unagi is built on this unique membrane-based system that allows for really precise and controlled exchange of your buffers. All you have to do is load your samples into our consumable that we call an Una here. And Unas can hold up to 8 mils of sample. So your volume range that you can run is anywhere from half a mil up to 8 mils. And once you have your sample in there, um, we just simply load up into what we have here on the right, which is a sample tray that can hold anywhere from 1 to 8 unas. And once those are loaded in the tray, that can be put into the instrument where it can go ahead and do that automated buffer exchange for you. Those unas have options for different membrane types. So we have 2 different flavors, either regenerated cellulose or polyether sulfone, or PES. And we have a wide variety of molecular weight cutoffs that are available for each of those as well. So you can pick the one that is most appropriate for your sample. So what makes our technology from Unchained Labs different from, other buffer exchange technologies that are out there? And really what it comes down to is this pressure-based ultrafiltration and diafiltration that we developed here at Unchained Labs. So if we look at this workflow, we can start on the left where we just simply input our samples. This is where you're going to, physically put your sample into the UNA and then put it into the instrument. So the first thing that's done when you put your sample in the instrument is we measure the volume. So we have an ultrasonic volume sensor inside of Unagi that allows us to measure the volume of each individual sample. So once we record the volumes of each, we then go through a pressurization cycle with mixing that allows the buffer to flow through the membrane while retaining your sample inside of the UNA. So after a certain amount of pressure and mixing time, we will then measure that volume again, and that allows us to get a flow rate, right? So we can see how much, sample or how much buffer is flowing through per given unit time. And that gives us a flow rate for each individual sample. And then those samples are then refilled with the buffer that we want to exchange into. So that's an iterative cycle that will continue to go until we reach our target exchange percentage. And once we have our exchange samples, we then have the option to concentrate those at the end as well. So if you want to concentrate your sample once they're exchanged, we can accommodate that too with the hardware inside of Unagi. So you may think, there are a lot of, membrane-based buffer exchange systems that are out there, or technologies typically around, the centrifugation type. And, the question is, how is this different from what we have at Unchained Labs? So a lot of the membrane-based filtration, we call that dead-end filtration. So while you are applying pressure, typically through centrifugation forces, your sample tends to basically pack up against that membrane, and that leads to a really inefficient buffer exchange. So what we do is we apply orbital mixing while doing that pressurization to make sure that that sample is homogeneous while we're doing our pressurization step. And that leads to a much more efficient and fast exchange, leading to, total, faster exchange times and more consistent exchanges as well. So another really cool application we can do with Unagi is to simply do a concentration step, right? So not only, say for example, you're working with a sample that you just purified, you've pooled all of your fractions together, and that sample is really dilute. You need to, basically concentrate that down into a smaller volume. So we can work with up to 48 mils of sample. You can load that into a 50 mil Falcon tube, and we can use that to reload our UNA rather than using a buffer that you want to exchange into. We call this reduced sample volume, the reduced sample volume application. So, after we refill that UNA, we can continue to do so with those pressurization steps in between to make sure all of that 48 mils of sample can then be concentrated down to 8 mils that will fit into a single UNA. From there, we can then go through just a basic concentration step to go from that 8 mils down to as low as half a mil if you want to do that. All of this can be done in parallel on up to 8 samples at the same time. So keep in mind, this is all automated, hands off, so you can do other things in the lab while your samples are concentrating using Unagi. So on the other end, if you're working with samples that are super viscous, right? If you're working with a high concentration antibody, something like that, we developed another application called dilute and filter. So what this does is it actually adds your exchange buffer, the buffer that you want to exchange into, before doing that first pressurization step. So what that allows you to do is to make sure that that sample does not get, too viscous to really slow down that exchange process. What this does is it makes that process much more consistent, allowing you to, limit how viscous that sample is going to get by adding that buffer first before doing the pressurization step. This really is ideal when you're working with really high viscosity samples, typically high concentration antibodies that people want to do buffer exchange for. So in developing Unagi, we had a lot of different samples that we did kind of baseline testing for to find the optimal conditions, right? And it makes it super easy for users in the software, right? So depending on the type of sample that you're working with, the concentration of that sample, and also what type of application you want to do, whether it's reduced sample volume, whether it is buffer exchange with or without concentration. We basically have 32 different presets in the software to be able to allow you to pick exactly what you want to do and your sample type to basically show you what the optimized conditions are. That being said, if you're working with a construct that is, a little bit different from other ones that are similar in concentration and sample type, say, for example, you're working with an antibody that you know is prone to aggregation, something like that, you can always customize those settings to be able to optimize it specifically for your construct as well. So let's take a look at what's inside. So let's look at some of the hardware that's inside of Unagi, right? So we'll start on the left side, and we're going to start with the buffer rack over there. The buffer rack holds up to 16 different 50 mil conicals, that's 50 mil conicals. And this is where you can store your buffers that you want to exchange into. Next to that, in the middle, we call that, or I call it the basement of the instrument. This is the buffer exchange chamber. This is where we do all of our pressurization to be able to have that buffer flow through the membrane. You can see loaded in that exchange chamber is the UNA sample rack with 8 UNAs inside of it. And next to that, basically above it, is the robotic arm. So that's the business end of the instrument, right? That's where all of our activity is happening. That has our liquid handling pipette head, as well as our ultrasonic volume sensor. Both of those are housed inside of that white robotic head. That physically moves over the samples and then over to your buffer rack to be able to pick up buffers for exchange. Below that is the disposable tip racks. So this is where we can house all of our tips that are going to be needed for doing our buffer exchange experiment. Behind that is a tip park, which is an optional way to be able to save tips and reuse them for that same liquid handling event in the future. And then behind that is the waste container where all of our waste is going to go. So everything is set up right on the deck in Unagi, ready to go in a well-organized fashion shown here. So after you're done with your experiment, the results that you get are very tailorable, right? So you can make it exactly how you want to see it. With this, we can see just kind of a basic showing our final formulation, showing what our initial concentration and final concentration was based off of the volumes that we have. It'll show us the percent exchange that was achieved for each one of our samples. But if you want to look at a little bit more detail, right? If you want to see, every activity that that robot did, everything that was in between and every one of those steps, we have both the experiment log and the raw report that you have access to that you can easily export or directly print from the software. You have options to do both. So I've spoken a lot about how Unagi is very simple to use, right? But I also want to focus on the quality of the data and the quality of the samples that you get afterwards. So in here, we are looking at examples of an experiment that was done with different IgG antibodies with these different types of applications, right? So whether it's buffer exchange with and without concentration or reduced sample volume application. So all of these were done with different initial and final concentrations of sample, but what I want to focus on is the recovery. So for every one of these different applications with these different sample concentrations, we were able to get recoveries of at least 96% for each one of these different examples. Last thing I want to mention is that all of our protein concentration was validated on either Lunatic or Stunner, which are our UV vis systems for doing protein quantification. All of these only require 2 microliters of sample, can be done in a high throughput format, and without the need for standards or dyes. So not only do we get those fantastic results and really high yields for, only an antibody, right? But if you look at these different types of samples, whether it's different size proteins, whether it is viral vectors or nucleic acids, for every one of these, we can have at least 90% recovery. And you can see here that we have, different target volumes for each one of these, as well as, different size molecular weight cutoffs that were required for each. So for example, BSA is got smaller proteins, so that's going to use our 10 kilodalton molecular weight cutoff. IgGs and thyroglobulin, larger proteins that can use that 30 kilodalton. And then once you're working with even larger molecules like viral vectors or whole DNA, that can use our 100 kilodalton molecular weight cutoff. So you can see with, regardless of whatever flavor of molecular weight cutoff we're using, we still get that high recovery with all these different sample types. All right. And with that, I want to transition over to talking about Unagi's big brother, which is Big Tuna. So, like I said before, it uses very similar buffer exchange technology with that pressure-based ultrafiltration and diafiltration. But here we really step it up to higher throughput. So with Big Tuna, we can have up to 96 different exchanges. We've basically increased that volume range that we can run anywhere from 100 microliters up to 48 mils of sample. And once again, just as before, less than 15 minutes required to load the samples, set it up in the software. You can hit start and let Big Tuna take the wheel. So biggest core difference here is this is a plate-based filtration rather than individual samples like we had with the Unas on Unagi. We can picture the unfiltered 24 here on the right. That's basically 24 Unas smashed together in a plate-based format, right? So we have very similar, volume ranges that we can work with there, very similar molecular weight cutoffs, and all of these in both these plate formats, everything is with regenerated cellulose or RC membranes. Now the unfiltered 96, that is, where we can increase that throughput even more and lower down the volume ranges that we can run too. So unfiltered 96s are compatible with anywhere from 100 microliters up to 450. And we also have the 3 kilodalton membrane available in the unfiltered 96, as this allows you to do more, oligo desalting, that kind of thing, which is typically done in higher throughput, which is why we have it available in the unfiltered 96. So when it comes to the time range, I always try to put these kinds of slides in here to give people an idea of how long it takes to do the buffer exchange. But also it's important to note that this is very sample dependent as well, right? So basically what I like to say here is, depending on the, concentration of your sample and the format of the, unfiltered plate that you're using, it can take anywhere from 1 hour up to 6 hours roughly in that time range. In this case, we're comparing antibody concentrations anywhere from 0.1 mg per mil up to 50 mg per mil. And if you're in that range somewhere, and I would expect the samples to be anywhere from 1 hour to 6 hours to do a full exchange. And with this, you can basically use that to easily plan around your schedule when you should start that experiment to make sure that you're not waiting there, late into the night to be able to expect that to finish. So just like with Unagi, we also have a very intuitive and easy to use software for Big Tuna as well. So one of the things that we developed with Big Tuna is, since we are working with higher throughput, the experimental design and the user interface needs to be, much easier to use, right? So with the when setting up the experiment, we can see in the top right there that on the left side we have our samples, and on the right side we have our buffers that we're going to be using for that exchange experiment. Basically, all you have to do is just click and drag which samples and which buffers are going to be in each well. And we have this kind of half circle color scheme where it's going to show us basically what buffer and what sample is in each one of those wells. So down there at the bottom, we have our basically progress of the instrument of the experiment that's going on. So as you're going about your day, doing other things in the lab, you can quickly glance over at the software. You can see, how close you are to finishing that experiment. So it's a really easy way to, check on that progress without having to dive into the software much further. When it comes to hardware on Big Tuna, we're going to see a lot of similarities to what we saw at Unagi, right? So a lot of the same hardware, just kind of, designed in a different way here. So we'll start on the left side, and that's where we have our ultrasonic volume sensor. So that is basically held in a little holster there on the left side. And when it's needed, it can be picked up and used to measure the volume of our different samples. Next to that, we have the unfilter that's housed in that same exchange chamber. So that exchange chamber, once again, is kind of in the basement of the instrument. And you can see it's loaded there with an unfilter 24. Above that, we have our 6-tip arm. So this is for doing any sort of, liquid handling and moving buffer into each one of those individual wells. Really cool about this is that it can change the distance in between those individual pipette tips. So whether you're working with an unfiltered 24 or 96, it will adjust accordingly to give you the most efficient buffer exchange and, adding buffer to each one of those individual wells. So on the right, we have the gripper, and that is what's going to pick up the volume sensor if we need to do any volume measurements, or it can also pick up pipette tips to move them where they're going to be available for that 6-tip arm to pick them up. So these are the different components that we have within Big Tuna. One other thing you're going to see is, behind the gripper that we have there are our buffer exchange reservoirs. This is where you're going to house our buffers for that you're going to be picking up and doing your exchange with. So those buffer reservoirs, they can hold more than the 50 mil conicals that we had on Unagi. So this can facilitate, higher volume exchanges as well. So when it comes to the types of experiments and where Unagi and Big Tuna can fit in, I want to focus primarily on protein characterization, right? So primarily for monoclonal antibodies, Unagi and Big Tuna that are capable of doing buffer exchange can do anything from sample cleanup. You can concentrate samples if they're too dilute, and also if you're doing any sort of formulation screen, which we're going to be talking about in the next couple slides. It's a fantastic option for doing that. Basically, you can do as many formulations as you need to for each one of your constructs and set those up for downstream processing. Downstream from that buffer exchange, we have two different products in our protein characterization portfolio that work great after buffer exchange, right? So if you want to characterize your protein, as I said before, if you want to measure concentration, that's where Stunner can come in, as well as doing sizing and aggregation. So it has dynamic light scattering to be able to check the quality of your protein after doing a buffer exchange. If you want to get more detail on that, that's where Auntie can come in. So we can measure protein stability, so like TM and TAG. Basically, we can measure light scattering during a thermal ramp to be able to see where your protein is actively unfolding, to measure relative stability in different formulations or with different constructs, things like that. We can also do isothermal stability. So if you want to test how stable your sample is over time, we can hold it at a constant temperature, all of that being able to be done in Auntie. So I want to talk about a quick kind of example experiment that we did where we took 4 different constructs, 2 of which are FDA-approved therapies, both adalimumab and trastuzumab, along with 2 constructs also that we had in the lab that we wanted to include. And the question here was whether each one of these different constructs, what was the ideal excipient combination for each one of these different constructs. So what we did is we took all 4 of these and we buffer exchanged them into 4 different buffers with different excipients, right? So it's essentially an excipient screen. So the same base buffers, histidine pH 6, and then we added different excipients, so either sodium chloride, sucrose, arginine, or a combination of sucrose and arginine together. So 4 constructs into 4 different buffers. This was a total of 16 different samples that we were comparing. So after buffer exchange, we took those samples over to Stunner, where we were able to check the sample quality. So we were able to check both size and polydispersity index for each one of those. Now, we would expect the sample, if it were monodispersed and well behaved, to be right around 10 nanometers for a monoclonal antibody. And we could see that for most of our samples, they were, which tells us the buffer exchange process utilizing Unagi in this case was, it treated the samples well, right? So the samples were not aggregated after doing that buffer exchange. With the one caveat of the large blue outlier bar that you see there for adalimumab in the presence of sucrose. So what this tells us is this is not the ideal formulation for that specific construct. And keep in mind, all of this was done with only 2 microliters of sample. All of these could be read in a single run on Stunner. And basically, we got our results in just about 10 minutes with all of these different samples to tell us, basically give us insights into which one of these is the ideal formulation and whether or not our samples were still well behaved after buffer exchange. So when it comes to buffer exchange, we really try to give customers the option. We have, basically a buffer exchange solution for automated buffer exchange, either low throughput or high throughput. So Nagi is really the benchtop buffer exchange solution that's totally hands-free, working with more low throughput users. But if buffer exchange is a huge focus in your lab or you're running through a lot of samples, that's where the automated big tuna can also come in. So depending on what your appetite is, as far as what anything from your throughput, your space constraints in the lab, this is where basically how we guide people towards whether Unagi or Big Tuna is the right choice for them. We know that Unagi is, more for those customers who are more low throughput. So if you're working with just a handful of samples a week, this is a great solution for you. But like I said, Big Tuna is more for, plate-based, high throughput buffer exchange for folks who are doing more, a ton of samples a week where buffer exchange is really the focus of their lab. When it comes to the biomolecule type, it's going to be the same that we can run on both instruments. And also, if somebody's looking to do more integration into an automation workflow, Unagi or Big Tuna is going to be a better solution for them just simply because we have that API capability for automation integration. So really, in summary, Unagi and Big Tuna are great solutions for automated buffer exchange to really reclaim your day, right? So to take that burden of having to babysit your samples while they're buffer exchanging either in the centrifuge or waiting for dialysis to finish, all of this can be done with Unagi and Big Tuna without user input. Let these instruments take your buffer exchange off your shoulders and get, consistent, high yield, high quality samples at the end. Whether you're working with, just kind of basic antibodies, if you have, a very, special construct you're working with that's going to be unique, we have full process control to help you optimize that for each individual sample. All right, and to kind of tie this all together and summarize this whole story, I want to look back to basically making those dinner plans that we had with your friends. The best way to go about something like this is to have, totally take charge and, give people just a couple options rather than leaving it totally open. This is kind of the same situation with Unagi and Big Tuna. How they really take charge of your buffer exchange and make it more organized and, keeping your samples more well behaved without the need to go through and optimize for each individual sample. So of course, with Unagi and Big Tuna taking those, you can then take that time to make sure you're doing more of these dinner dates with your friends, making sure you're maintaining your social life as well. So I want to thank everybody for joining today, and I would love to invite any questions that you may have. Thank you. Back to Ross.
Hey, Brian, thanks for that. That was really great. And actually, you know what? I've had exactly that issue that you're talking about with everybody trying to go out to dinner together, but it's just me and my wife, and we still can't make a decision. So, uh, the people in the audience have already submitted some really great questions, and we're getting closer to time. So I think we're going to stay maybe 5 minutes past in order to get to all of those, and we're going to get right into it. Before we start the Q&A, if anybody in the audience still has questions, you can still ask them by entering them into the Q&A section of the Zoom navigation bar. So let's get into it. So first question is, Do the samples need to be of the same kind, or can each sample be different?
So when you're setting up the experiment, you need to have the same conditions for each one of them, right? So when it comes to the pressurization, when it comes to the how much volume that we're removing per cycle. That all has to be consistent between all the samples that you're working with. So we recommend, so for example, if you're working with just monoclonal antibodies, you want all of your samples to be monoclonal antibodies. Otherwise, you're going to have some that maybe are, too much buffers removed per cycle. So we really recommend that they stay consistent between that sample type with all the samples that are being run together. So.
Cool. In that sort of vein, how do you handle samples that are run at different rates within the same experiment?
Yeah, so for example, I think I've seen situations like this, or if you're doing a formulation screen where clearly in that example that we had, there were some samples that aggregated and some that didn't. And that can have a big difference on the flow rates, right? So one of the things that we can do with our buffer exchange is after each pressurization cycle, we also measure the or we measure the volume of each, which gives us a flow rate, right? So we always try to optimize our pressurization times off of the fastest flowing sample to make sure that that sample doesn't dry out. So what that does is that's basically a process that's optimized after each pressurization step to make sure that we are optimizing and making sure that we don't have samples that are drying out at the end. So, that's how we're able to basically compensate for samples that are, higher flow rates and lower flow rates at the same time. So,
Gotcha. Okay. So does Unagi or Big Tuna offer temperature control? And if not, could we put it into, say, a cold room, for example?
yeah, good question. That's one that we get a lot, and a lot of people are convinced that they need to, keep their samples cold while doing buffer exchange. And one of the caveats to that is buffer change takes a lot longer when you cool everything down. So, short answer is we don't offer temperature control, and we don't recommend putting the whole system inside of a cold room, just simply because cold rooms tend to be really humid environments because it's being cooled in there, and that can have an effect on our volume sensor. So we recommend doing the buffer exchange at room temperature, and then once it's completed, you can take that sample and take it directly into the cold room from there.
Gotcha. And then, sort of in the same on the same line of question, is there an ability to control light exposure to sample if the samples are vulnerable?
Yeah, good question. You can, certainly, during the buffer exchange or during those pressurization steps, everything is protected from light, right? You're in that pressurization chamber, the door is shut. So there's not that much time that the sample is actually exposed to light. That being said, we have seen some creative solutions where people have basically put like a light tight box around the whole thing with Big Tuna, essentially. Unagi, on the other hand, already has that door on the front that's going to be protecting your samples from light, so that's not really a concern when it comes to Unagi.
Cool. And then, can you speak to integration of other downstream tools with Big Tuna? For example, integrating Auntie with Big Tuna as a high throughput screening paradigm.
Sure. Yeah, absolutely. I think, Big Tuna does play well with other instruments for downstream processing, right? Especially in the fact you think of your, example of everything is run on a 96 well plate. You can then take those samples and directly load them into Auntie plates, right? So, which is also in that 96 well plate format. Both of those are compatible with liquid handlers. So you could simply pick up your samples and take 8 microliters of those, load them into an Auntie plate, and all this can be done totally hands off. So absolutely something that can be done.
Yep, it's exciting time to be working in formulations for that very reason.
Yeah.
Um, okay, so we've got a few questions here that are all about various types of components that might be usable or might that to find out if Unagi can handle them or if Big Tuna can handle them. So I'm just going to kind of list them all together. Somebody's asking about serum depleted IgG. Somebody's asking about doing cell culture media exchanges, and then just are there any buffer components that are just not compatible with Unagi or with Big Tuna?
Sure. Yeah. I mean, cell culture media, I mean, there's so many different components in there. I would be concerned more about that sample clogging the membrane. But as long as you're keeping that shaking happening, you should be able to get that done. As far as serum depleted IgG, I see no problem with that. I think that's something that we've seen people have used that in the past. And when it comes to buffer components that can be an issue for the buffer exchange systems, I would say if you're working with surfactants of any kind, you need to be careful just simply because if your sample has bubbles, things like that, that can lead to inaccurate volume measurements just simply because the bubbles are on top of your sample. So the workaround for that is, since it is fully customizable, you can, change your shaking speed and duration of shaking during your pressurization cycles to make sure that we're not generating bubbles on top of your sample. So,
Sure, that makes sense. Yeah, and with regards to specifically with cell culture, I've also when we're thought about keeping things sterile is always tricky
sure.
as
Yeah.
well. So okay, and then this is also kind of related: is can I buffer exchange samples other than proteins?
Yeah, absolutely. Yeah. There were a couple examples that I showed in there, but if you're working with, the nucleic acids, you're working with viral vectors, absolutely. These can all be used with Unagi or big tuna. So basically the example here is, if it fits within the molecular weight cutoff filters that we have, we could exchange it. So
Fantastic. All right. Well, I do want to say thank you to everybody. Thank you, Brian, for this great presentation. Thank you to all of everybody who asked questions. If we haven't gotten to your question yet, we'll be reaching out to you via email and be able to answer them that way. If you want to have a deeper conversation with our team or have a question occurs to you later, please get in touch with us at info@unchainedlabs.com or learn more at our website, www.unchainedlabs.com. We would love to connect with you. Thanks again for attending our virtual seminar and have a great rest of your day.
thanks.